Okay, so let's identify some of this information on a graph. So we'll do intervals increasing, decreasing, and constant, and we'll look for relative maximums and minimums. Let's see what we've got. So we'll pretty much go, I guess we'll go in that order, sure. What should we do? Let's organize it. Let's put our intervals down here. Intervals. So increasing. I'm actually going to list all three of these. This is slightly different than how the homework has it laid out, right, where you're kind of doing them one at a time. But I think for us, just in this example, it might be helpful to kind of look at all of these at the same time. We'll kind of just go on our graph from left to right, and as we sort of hit a particular interval, we'll just include that as either increasing, decreasing, or constant. So again, the thing to remember is we're doing this from the perspective moving on our x's from left to right. So we're sort of generally moving this way, which means right kind of along the curve. If we start to sort of draw some arrows in, right, what kind of things we're doing, right, again, if we were thinking of this like a roller coaster that we were riding, right, this is the kind of motion that we would be doing. And if we start to draw some of those arrows in, you can really see the behavior, I think, pretty well, right? If you kind of imagine yourself, if you were riding on this like it was a roller coaster or something, you can imagine, well, so pretty clearly, right, starting back here at, so what is this, negative 1, 2, 3, 4, at x value negative 4 is really where this function starts, and pretty much right off the bat we're decreasing down to this coordinate, which would be, so x is negative 2 and the y is 0. When we write these intervals, we're only talking about the x values. The y values, right, because this is a function, it's okay for the y values to repeat and show up more than once, which means I can't really list an interval uniquely by just listing the y values. The y values are going to show up in this case more than one time. So as far as these intervals goes, they really need to be x intervals. So my first section from negative 4 to negative 2 is a decreasing function. I'm dropping down to this low point. So I'll just start that over here. So negative 4 to negative 2. I guess we'll do decreasing in red. The next interval, right, the next section on the graph would be, right, we sort of turn here at the bottom and then we head upwards to about x equals 0, right? Again, the height here is 3, but I'm not really identifying these intervals by the height coordinates necessarily. I'm just using the x values, right? So sort of from here to here. So this for us, right, is negative 2 to 0. We're increasing. The function is getting larger, right? The y values are getting larger. We're sort of headed uphill. When I write these intervals, I'm only going to write them as open intervals with parentheses. The like actual sort of like peaks. This is a peak. This is a valley, right? The actual sort of endpoints of these intervals, you know, you could kind of make an argument whether to include them in sort of which case, an increasing or a decreasing. They're really neither, and they're not really constant, just at single points. So what we're really doing is, honestly, we're just going to sort of leave them off. All of our sort of max and min points, we'll identify them when we do the relative maximums and minimums, but as far as right, identifying these guys for increasing and decreasing, we're just going to use parentheses exclusively. You can see we'll go through these next couple a little faster, right? So the next section, this guy's a relatively kind of balanced function. So going from 0 to positive 2, we've sort of started to drop again. So what I'm going to do is I'm going to use a little like U for union. So this just means, so interval 1 and interval 2. So it's the interval from negative 4 to negative 2, which was this guy. And also this interval here from 0 to positive 2. Right, so we're including both of those intervals. You could use a comma, I guess, but the union I think is more common and has a little bit of a better look to it. the last interval, even though there's sort of two different behaviors happening, starting at positive 2, obviously we're sort of headed up, and then we sort of change what the function is doing a little bit. Instead of sort of doing this more parabola kind of shape, we just break into more of a straight line. But over that whole section, the function is getting larger, right? The y values are increasing. So we're just going to list this. So starting at, so what is this, positive 2 in the x's, and we're going to assume that that happens all the way, out to the sort of ends of the number line, right, out to infinity. That this behavior is just going to keep going up and up and up and up, all the way to infinity. So intervals increasing, negative 2 to 0, so this section here, and then from positive 2 all the way out to infinity. Are decreasing, we were dropping here negative 4 to negative 2, and then here from 0 to positive 2. That pretty much takes up all the function, right? That means in this case we don't really have any flat sections. There's nowhere where we're plateaued. So as far as having an interval where we're constant, we just don't. We don't. So interval of constant, in this case, there is none, and so we'll sort of mark it that way.